Look up. On a clear night, far from the glow of any city, the sky above you contains roughly 5,000 stars visible to the naked eye. With a modest telescope, 10,000 times that. With the instruments we have built in the last century, hundreds of billions of galaxies, each containing hundreds of billions of stars. The numbers are almost meaningless. The scale is beyond the reach of human intuition. But stay with them for a moment. In 1961, a radio astronomer named Frank Drake sat down in Green Bank, West Virginia, and wrote an equation, not to calculate a definite answer, but to organize a question. The question of how many civilizations might exist in our galaxy right now, capable of communicating with us across the void. The equation multiplied together the rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction where intelligence emerges, the fraction that develop technology, and the length of time such civilizations survive. Plug in even conservative estimates for each term, and the number is not zero, not close to zero. The numbers suggest that our galaxy alone should be teeming. Thousands of civilizations, tens of thousands, perhaps more. The universe is 14 billion years old. Stars similar to our sun have existed for 10 billion years. Life on Earth emerged within the first billion years of our planet's formation. If life is common, if intelligence is a natural consequence of complexity given enough time, then the cosmos should be full of it. Ancient civilizations. Civilizations so advanced that the gap between them and us is the same gap between us and a single-celled organism. Civilizations that have had billions of years to expand, to build, to reach outward. And yet, in 1950, a physicist named Enrico Fermi was eating lunch with colleagues at the Los Alamos National Laboratory. The conversation had drifted, as it occasionally does among physicists, to the possibility of extraterrestrial life. Fermi listened. He looked at the numbers. And then, with the directness that characterized his thinking, he asked a question. Where is everybody? The Milky Way is not young. The oldest stars in our galaxy formed roughly 13 billion years ago, within a billion years of the Big Bang itself. The conditions for rocky, Earth-like planets have existed for at least 9 billion years. If a civilization emerged on one of those ancient stars, if intelligent life first arose 9 billion years ago, or even 5 billion years ago, and if that civilization expanded outward at even 1% of the speed of light, which is well within the theoretical reach of advanced technology, they would have had time to colonize every star in the Milky Way. Not 1,000,000 years, not 100 million. At modest expansion rates, a single civilization could fill the galaxy in less than 2 million years. The galaxy is 10 billion years old. 2 million years is 2/10,000ths of that. In the time the galaxy has had to produce and sustain intelligent life, a single motivated civilization could have traversed it completely, not once, but 5,000 times over. In 1964, Soviet astrophysicist Nikolai Kardashev proposed a framework for classifying civilizations by their energy use. A Type 1 civilization harnesses the full energy output of its planet. A Type 2 harnesses the full output of its star. A Type 3 commands the energy of an entire galaxy. We are not yet Type 1. We are somewhere around 0.7, a civilization that still burns ancient sunlight trapped in rock to power our machines. A Type 3 civilization would be energetically 2 billion times more powerful than we are. Their works would be visible across intergalactic distances. Their engineering would reshape star systems. Their signals, if they chose to send them, would be detectable across the observable universe. We have been listening. For over 60 years, the SETI program has scanned the sky in radio frequencies, optical frequencies, infrared. Thousands of hours, millions of channels, enormous sensitivity. The sky is full of signals, pulsars, quasars, the hiss of the cosmic microwave background, the afterglow of the Big Bang itself, still reaching us from every direction. Not one signal has been confirmed as the product of intelligence other than our own. In 1977, a researcher named Jerry Emmon was reviewing data from the Big Ear radio telescope at Ohio State University when he noticed something. A burst of radio signal at exactly the frequency hydrogen emits, which many physicists considered the natural choice for interstellar communication, 30 times stronger than the background noise. It lasted exactly as long as the telescope's field of view, 72 seconds. It came from the direction of the constellation Sagittarius. Eamon circled the printout and wrote a single word in the margin. Wow. It has never been detected again. The silence is not nothing. The silence is data. And what the silence is telling us, if we are willing to hear it, is one of the most disturbing things the universe has ever communicated. In 1998, economist Robin Hanson published an essay that reframed the Fermi Paradox in a way that has haunted physicists, philosophers, and anyone who has read it carefully ever since. Hanson called it the Great Filter. The idea is this: between the birth of a star system and the emergence of a civilization that spreads across the galaxy, there are many steps. Each step must be crossed, and somewhere along that path, somewhere between simple chemistry and star-faring intelligence, there is a barrier so difficult, so improbable, so catastrophically hard to cross that almost nothing makes it through. We don't see the galaxy filled with civilizations. Therefore, something is stopping them. Something is filtering them out. That something is the Great Filter. And now comes the question that once asked cannot be unasked. Where is the filter? Is it behind us, or is it ahead? If the Great Filter is behind us, if we have already passed through it, then we are the miraculous exception. We survived something that almost nothing survives. The steps we take for granted, the formation of a planet in the habitable zone, the origin of life from chemistry, the emergence of eukaryotic cells, the development of sexual reproduction, the evolution of complex nervous systems, consciousness, language, civilization. One or more of these steps is so fantastically improbable that almost no other path in the galaxy has ever replicated it. We are the extraordinarily lucky. We are the 1 in a trillion outcome that happens anyway, because the universe is large enough to guarantee it eventually. This is the rare Earth hypothesis, the idea that Earth is not typical, that the conditions required for complex life are so specific, so finely layered, that the galaxy is effectively empty except for us. If this is true, if the filter is behind us, then the universe is ours. We survived what nothing else survived. We are alone. And the silence of the sky is not a warning. It is a confirmation. But if the Great Filter is ahead of us, if we have not yet crossed it, then the silence of the sky is a forecast. Every civilization that has ever reached our level of development has been stopped, destroyed, erased by something that awaits them at the next stage. And we are approaching it now. What is it? We don't know. That is the most terrifying part. It might be nuclear war, technology that arrives before wisdom. It might be a biological catastrophe, engineered or accidental. It might be artificial general intelligence that pursues goals misaligned with human survival. It might be a physical limit we don't yet know exists, some property of high-energy physics that destroys any civilization advanced enough to probe it. It might be something no human has yet imagined. But if the filter is ahead, if every civilization that reaches our stage has been stopped, then the universe's silence is not empty. It is a graveyard. And here is the most chilling implication of all. When we discover signs of life elsewhere in the universe, when we find microbial fossils on Mars, or amino acids in the oceans of Europa, or complex chemistry in the atmosphere of an exoplanet, most scientists would consider that a triumph, a confirmation that life is common. But if life is common, and intelligence is still rare, and the galaxy is still silent, then the filter cannot be the origin of life. It must be something later. Something we haven't crossed yet. The discovery of simple extraterrestrial life would be, simultaneously, the most exciting discovery in human history, and potentially the worst news our species has ever received. But perhaps the Great Filter is not the only explanation for the silence. Perhaps the universe is not empty. Perhaps it is simply quiet, by choice, or by necessity. In 2008, Chinese science fiction author Liu Cixin published a novel called The Three-Body Problem. In its sequel, he articulated what he called the dark forest theory of the cosmos, and it has never left the minds of the physicists and philosophers who encountered it. The logic is cold and beautiful, and terrible. Every civilization in the universe faces the same fundamental problem. Resources are finite. Survival requires them. And a civilization that is detected by another civilization cannot know whether that other civilization is friend or predator. You cannot communicate your intentions reliably across interstellar distances. You cannot verify the claims of a stranger you have never met and cannot reach for thousands of years. The only rational strategy, if you believe the universe contains both cooperators and predators, and you cannot tell which is to strike first. Eliminate any civilization you detect before it can detect you. In this model, the universe is not empty. It is a dark forest. Every civilization is a hunter, moving silently through the trees, extinguishing any fire they see, because a fire reveals a position, and a revealed position is a death sentence. The universe is silent, not because it is empty, but because every civilization that survived learned the hard way, or in time, to never announce itself. We have been transmitting for over a century. Our radio and television signals have been radiating outward into space since the early 1900s. The sphere of our electromagnetic presence is now roughly 100 light-years across. If the dark forest theory is correct, we may have already been heard. Not everyone finds the silence menacing. The zoo hypothesis, proposed by John Ball in 1973, suggests a more benign explanation. Advanced civilizations are aware of us. They have chosen, for reasons of science or ethics or aesthetics, not to interfere. We are a nature reserve, a specimen, observed but not contacted. Perhaps there is a protocol. Perhaps civilizations throughout the galaxy have agreed, as we ourselves have debated regarding uncontacted tribes on Earth, that young civilizations must be allowed to develop without interference. that contact, before a species is ready, is a form of violence. We are in a zoo, and the silence is the patience of its keepers. Or perhaps, and this connects to questions at the frontier of theoretical physics, the silence has a computational explanation. Perhaps the universe is running on a substrate that imposes limits, and simulating full civilizations is computationally expensive. So most of the galaxy is dark, because most of the galaxy is not being simulated. We are not alone. We simply have not been rendered yet. These hypotheses range from the comforting to the horrifying. None of them have been confirmed. All of them are consistent with the available evidence, which is essentially silence. The silence accepts every explanation and confirms none of them. That is its power. That is its cruelty. We have been asking the question for 60 years. We have built instruments of extraordinary sensitivity, pointed them at every corner of the accessible sky, cataloged millions of signals, and found nothing that unambiguously answers back. The silence has not broken. And yet we have also, in these same 60 years, discovered more than 4,000 exoplanets, planets orbiting other stars, many of them rocky, many of them in the habitable zone, many of them orbiting stars that have been burning for billions of years. We have found the chemical precursors of life in interstellar space. We have found that the conditions for life, at least as we understand them, are remarkably common. The ingredients are everywhere. The chefs are nowhere to be found. Consider what we know. We are a species that has existed for approximately 300,000 years on a planet 4.5 billion years old, orbiting a star that formed 5 billion years ago, in a galaxy that has been here for over 10 billion years. We learned to read and write roughly 5,000 years ago. We discovered the laws of electromagnetism 150 years ago. We split the atom 80 years ago. We sent our first message to the stars in 1974. We are young. We are small. We are, by any cosmic measure, astonishingly new. And yet, here we are, asking questions about the nature of reality, about the origin of the universe, about the fate of consciousness, in a cosmos that has been running for 14 billion years, without anyone, as far as we can tell, asking these questions from a confirmed position. That is remarkable, not as comfort, not as a reason for complacency, but as a fact that deserves to be held carefully and seriously. If the great filter is behind us, if we are genuinely rare, genuinely improbable, genuinely the first minds of our kind in this part of the cosmos, then we carry something unprecedented: the responsibility of consciousness in a universe that produced it against enormous odds. And if the great filter is ahead, if we are approaching the wall that has stopped every civilization that came before us, then what we do in the next century, the next 50 years, the next decade, matters in a way that nothing else could. Not just for us, for everything that might come after. Because here is the thought that the Fermi Paradox ultimately leaves us with. If we survive, if we navigate the filter, whatever it is, wherever it lies, then we become part of the answer to the question. We become the evidence that it is possible. Every civilization that wonders whether it is alone, every intelligence that looks up at its sky and asks Fermi's question, will have in us a data point. It can be done. The silence can be broken. Not by being first, we don't know that we are first, but by being one of the ones that made it. We do not know if the universe is full of life waiting to be found, or empty in a way that should terrify us, or full of life hiding in a darkness of its own making. We do not know if the great filter is behind us or ahead. We do not know if we are the miracle or the warning. But we are here. We are asking. And the asking itself, the act of pointing our instruments at the dark and listening with everything we have, is perhaps the most important thing a civilization can do. Enrico Fermi asked his question over a lunch table in 1950. We are still at the table. The universe has not answered. But it is listening. And somewhere out there, in the silence between stars that we have not yet learned to read, there may be another civilization, sitting at its own table, looking at its own sky, asking the same question we are asking now. Where is everybody? We are still here, still asking, still listening. And for now, that has to be enough.